Intermediate systems and switching systems, they hold the internet together. They interconnect the different physical networks and perform the transformation. So the physical systems that are involved in the internet are interlinked with the help of these intermediate systems that take the task of packet switching between different networks and of all the translation work we discussed, which is necessary in an internet. But if we have a closer look to the intermediate systems, then we will see that there are intermediate systems with very different functions. So we have repeater, we have hubs, we know bridges, switches, we know router, we know gateways. All are intermediate systems with different functionality. According to their functions, we can associate these different systems to different layers in the protocol stack. And this we'll look in the next slides. First type of intermediate systems are repeater. Repeaters work at the lowest level, the physical layer of the protocol stack, and for that reason they are invisible for higher layers. They serve purely in the amplification of the signals, so that they allow to transmit data over a greater distance. Repeaters have no intelligence. They cannot use to transform something. They only amplify signals so that the packet can send over longer distance. Here in the picture we see that's the functionality on the hardware layer. Bridges and switches are on the next layer, are associated with the next layer. Bridges connect two local area network segments, and switches connect individual computers to local area networks or multiple segments. So what the bridges and switches allow is that they have some intelligence to realize whether a data packet from one segment needs to be transported into the another segment. And only in that case the bridges hands over the data packet to the other segment. If the receiver is inside, then the packet is not broadcasted to the another segment. So in this way, the bridges and switches take care that local traffic stays local and is not forwarded over the bridge. So in this way, the bridges and switches are acting on the network layer, on the second layer. More advanced are routers, and routers are associated with the next layer, with the internet layer. So routers may connect independent networks to an internet. So it's no more like in case of bridges and switches that from the same local area network technology segments are connected. Now here routers are able to interconnect independent network technologies to a network. So they separate subnetworks at the protocol layer, or the protocol stack layer 2. Network topology and technology must be known to the router, otherwise a router is not able to make this forward of the packet, to make this transformation. And in this way the router acts on the IP layer of the TCP IP protocol stack. On the next layers, gateways are working. Gateways, or more precisely application-level gateways, they connect networks at the application level. So all communication between two application or components of a distributed application that run on different systems in different networks may exchange information via such application-level gateways. So they are able to translate the special application protocols that are used by the application to use the internet for their transport purposes. So here you see the application gateways are acting on the application layer of the TCP/IP protocol stack.